Hello everybody, we're going to talk about section 18G, which is about dealing with more complex integrals and kind of a neat trick called integration by substitution. So if you had to evaluate the following, you have to think about what you're going to do. And if we were in class, we'd spend some time thinking about it. If you want to, you can pause the video here and think about it. But I hope you would notice that this factor here, 2x minus 3, is the derivative of what's in the brackets here. And this one you can't see. They actually gave you a substitution to use but it's something similar. What I really want you to notice here is that this is the derivative of this part inside the brackets. So that means that we can use that, okay? And just like we did substitution solving, we've used this trick before where we've let something complicated be called something simple like u, and then we've replaced it to do the math, and then when we did the hard math, we replaced it back. This is the same idea. Here, we're going to let this part that's complicated, the part that gives us this derivative, be called u. Then I can replace this function right here with u to the 4. The problem is now I have an integral where I have a u to an exponent and I have an x. And so I have too many variables. But I notice that if I take the derivative of u, so remember that we called this part in the middle u, the derivative will be 2x minus 3. And remember we call the derivative du by dx. If I flip this fraction around a little bit and isolate for dx, I end up with du over 2x minus 3. Now, if I substitute that into my expression for dx, remember I told you that dx is important. If I substitute that in for dx, now I have 2x minus 3 times u to the 4 times du over 2x minus 3. And this 2x minus 3 and this one can cancel out, leaving me with an integral that I can solve, which is u to the 4 du. And I even have the appropriate notation here, which means that I'm taking the integral with respect to u. This one I know is u to the 4, u to the 4 plus 1 over 4 plus 1, or u to the 5 over 5 plus c. Okay, but I'm not done because I've got to change this back to x. Remember we started with x as our variable, so we've got to put that x squared minus 3x back in for u, and I end up with this expression, which I could write in this form or in this form. Likewise, in the other example that I asked you to think about, we missed this part where it said using the substitution 2x squared plus 5. Okay, so it's telling us that we want to take the complicated part, the part that's raised to a power, and that's what we want to call u. That's what we want to simplify. So I'm going to call this part that's raised to the power of 3 u. I'm going to take the derivative of this, which gives me 4x, and then I'm going to solve for dx, which is going to leave me with du over 4x. Now that doesn't match 6x exactly, but it is going to help. When I change this part of my expression to u and this part to du over 4x, now I have the expression 6x times u cubed times du over 4x, and the x parts can cancel out, leave me with just 6 over 4 u cubed du. Okay, now I can simplify that by pulling out that 6 over 4 and reducing it. I can take the integral of u cubed du, which is 1/4 u to the 4, multiply it by 3/2, and I get 3u over 8, 3u to the 4 over 8 plus c. When I replace that u with the x expression, the expression in terms of x, now I have my integral. Okay, so the key to substitution here is that the integral should now not have any x's in it. Once I've substituted, I should cancel out the x's and be left with just u's. Then I can go ahead and integrate. Okay, so in the next video, we're gonna do some examples from scratch where we use this strategy. Thank you, and continue to the next video.